that it?
Yep.
Yeah.
Good. Good evening, everyone. It's a pleasure to be talking with you this evening about this. I'm quite passionate about STEM and regional academies, colleges, apprenticeships, universities. I've spent the majority of my career trying to get intellectual property and interesting programs that were between us in partnership with academia, AMRCs, and industry. We actually innovate for benefit, which is a key point for me. And everything I've seen that we need to do, which is why I made the comment about the commercial training before, it's much better when we look at market-driven requirements. I understand the need for pure research, and that's got its place, but market-driven requirements are important. We're becoming in danger of becoming thought leaders in the UK, which doesn't actually develop very many jobs. So ownership of intellectual property is very important. So we as a consortium, which I lead, has been developing a small modular reactor entire nuclear power station for the last 4 years. You've probably seen in the media that we achieved match government funding, which is up to the end of the equity failure phase, so up to the point where we could get private equity from the market, and that's when we've achieved the regulation, the generic design assessment through the Office of Nuclear Regulation. So you see a list of companies on your left-hand side. It covers the span of all the parts of the power station, civil engineering, turbine systems, turbine island, cooling water, the reactor plant itself, which is actually only 20% of the capital cost of the station. The balance of plant and the steam turbine islands 40%, civil engineering is 40%. For the critical path of the programme, it's actually the regulation and licensing, not just the nuclear, but development consent orders and site licensing. So regulation's the first critical path, and the second is certainly through the civil engineering. So if I move on, why are we developing this? Because we're aiming for net zero as a legal requirement now in the UK. But also, as I said, it's the first time we've developed a nuclear power station for over 40 years, a civil one in the nuclear industry. Obviously, we've done defence submarine reactors over the years, but this is the first civil nuclear one for over 40 years. It will bring significant opportunities for supply chain and jobs, but as we go through the market, it's huge. This is just the UK. But what you will see is everybody obsesses about electricity, and it's a tiny proportion of the decarbonisation target. The majority of it is on fuels of all sorts, and particularly one reason why you might say, okay, Rolls-Royce does nuclear, but not very big in comparison with civil aero. Well, you'll notice Jet A at the top there, and in the future with net zero, you may get regional aircraft with hybrid electric or hydrogen even powered engines, but you won't get transatlantic or long-haul aircraft. You'll still need the full jet engine. Therefore, to go net zero, you have to go to synthetic fuel. And that's going to be massively important to keep the aero industry going during going to zero carbon. It will be a massive challenge. You look at that, and it's the equivalent to decarbonise that market I told you before of 153 gigawatts. We believe in a balanced energy market, but you can see that renewables, if you tried to develop that, and this is where power density comes in, it'd take all of Wales, the Irish Sea, up to a portion of Ireland, most of Devon and Cornwall, and getting towards London to do it with wind farms. If you do the same thing with the power density on a nuclear stations with SMRs, for example, it'd be 18 square kilometres. So the other reason we developed this was that you've all probably seen the issues with large reactor plants on delivery. We'd realised about 6 to 8 years ago that there were only going to be two winners in the large nuclear power market in the world, and that was China and Russia. And that was because their drivers are not necessarily commercial, they're political majoritively, and they make no secret of that. But the large reactors have actually got to a size where technically and financially it's becoming difficult to deliver them. They've almost got now to the absolute nadir of what they can produce. So we believe the answer was we needed a commercially investable reactor station. It's small in physical size and power output to a large reactor. The footprint you can see there is supposed to represent about 1.5 Wembley stadiums if you're a football fan, but that station, if you're a music fan alternatively, would fit under the O2 footprint as well. It's to do with economies of volume over scale. It's factory manufacture of everything above ground at the whole power station, and modular construction, reducing the construction cost and risk. The actual programme attracts quite high rates for investment because they are seen as risky programmes. If you take the majority of that risk off site and make it transportable by road or rail, then you actually remove a lot of what people see as risky site work. And I'll come on to weather and disintermediation as well in a slide or two. But that's the whole point of it. There is an innovation we have to do to make that possible, because we don't just want to sell these in the UK. We've got interest from Commonwealth countries, from Central Eastern Europe, from Turkey and the Middle East. So there's already quite a lot of interest in the development. Some of these governments are working with us now to develop. Market-driven requirement, I'll skip over that, but that's a detailed analysis of the market globally and what's closed and open to us. I've talked about this, but our design's got to be designed for performance, designed for safety, designed for manufacture, designed for reliability and maintenance, and designed for decommissioning. So there's a lot of designs there. I know Gary raised the TRL and MCRLs, technology readiness and manufacturing capability readiness levels. But we also have a process, and they've had it in Rolls-Royce for just over a decade now, which we call integrated. We call it integrated product and production readiness. And what that does effectively brings all the skills into the design team from the start to not just look at the design concepts, but their affordability and deliverability, both through starting doing embryonic business cases on things like, for a power station, the levelized cost of electricity and comparing it with other outcomes, the supply chain and the confidence you have in that, and the entirety of the delivery model. And from an embryonic stage, as I say, we start that right at the beginning of development programs now. So I'll skip over this, but levelized cost of electricity is what drives this one. It could be fuel efficiency, thrust, and aerodynamics for an aero engine. They're all different. Our design, looking at a little bit more detail here, as a optimized civil construction layout. Langor Rock do civil modules now at workshop for hospitals and large infrastructure programs. All we're intending to do is take those off site with rebar put in them in advance as modules, and almost stickle brick build, if you will. It's a massive Lego set, really, more than anything else. The primary plant is a stick plant, but each of those components is transportable. The power level was driven by the transportation requirements. The reactor pressure vessel is a 4.5 metre diameter, and it's around about 300 tonnes in weight and 8 metres. It's actually 14 meters when you put the head and the control rod drive mechanisms on, but you transport those separately. And that drove the power level, because that size allows you to put 121 fuel elements, low enriched uranium in. That gives you 1276 megawatts thermal power, and via the good old Rankine cycle and some good work by Siemens, who improved that Rankine cycle a little bit for us, you get 440 megawatts electric. If you look at the bottom, we have marine and electrical modules as well. And Gary's probably well aware that we actually have a full-scale trial of this one shown here is the primary circuit chemical treatment modules, and we've got that in Factory 2050, which people can go and have a look at as full scale, because that's the most complex of the entire system, and it goes through the containment boundaries as well, and it was entirely doable. So that gives us high confidence that we should be able to do the rest in the future. I'll skip over the business model. What I want to cover here is the sensitivities. When you look at large reactors, what you have here is you have power output and capital, which are important. So overnight cost of capital, it's called, that they measure as a measure of economics for power stations, but it's not a great measure, because you can see that by far the highest sensitivity is on the weighted average cost of capital, and that's the interest rate that's attracted by the risk of the programs. So the more you can reduce the delivery time and get economies of scale and go through learner curves in factories, the more improved cost you get, the more improved benefit, and the lower cost that banks will lend you for investment or the government prepared to pay for. I've mentioned it's designed for all aspects of the life cycle. There are 3 factories that we're going to have. There's the primary components factory, there's the modules facility, and there is the civil modules facility as well. That may be an extension of workshop, but it's going to be a large facility. Sheffield area is a candidate for the primary components facility, are some others. So innovative ideas appreciated on those. And the module factory, our intent is a lot of this work and the up to 40,000 jobs in the UK can go in typical industrial northern areas, which is a great benefit from a Lancashire lad as well. The other factory, we call it, and this is an earlier version, it's been developed since this picture, is a side canopy. Again, because of our small footprint, we can entirely enclose the build as well, so we disintermediate weather conditions. If you look at somewhere like Wilfer for a large reactor, that could add 18 months to the programme timescale just by the weather in the UK. The big one that we need to do, when I said disintermediating site conditions, is developing an aseismic bearing, which removes any seismic activity so that everything's standard above that. So whichever country you're in, Turkey, which is high seismicity, Indonesia, similarly, all require or all would like to buy these stations. So we have to make sure everything's standard above so we can maintain the learner curve. We do have a complete modular approach, and this is just a blow-up of the outline civils that's been done as well. We've now got it on an entire Revit drawing, and it's being done digitally as well. So our intent is to have a spine of digital information right from the start, right the way through. Our pass-off facilities are going to have all digital pass-off for size, NDE capacity, all the rest of it, and similarly into the supply chain. My vision of this is that we'll have one whole digital model, but it's not just a bin for configuration control. I want it to be a dynamic model because we're going to have all our systems data and equipment performance data built in behind that that's going to be able to be accessed through life and by the supply chain. As we go through the process for major suppliers, we're actually bringing them in as well, and where they've got advice from their knowledge, then we're inputting that into the IPPR process I mentioned earlier. I mentioned about the impact of weather, and you can have a look at that in slower time. This looks a bit like Thunderbirds, but it's not. The top one is the kind of process that they use for NASA space rockets. So this is what we've had a study done on, and we're looking at a similar system. Because we are talking volume production, when we do our market assessment, we could be up to 4 stations per annum when we get up to speed with these, each one being between about 1.5 and 1.8 billion. The bottom one, I do have videos of this, but it's a mock-up of a modular facility as well that we've done along with the AMRCs. And I mentioned about digital. We've got extensive knowledge of that, not just in aerospace, but in marine. And our intent is to retain the technical authority and be able to give customers a central ops centre for analysis and do complete reliability centred maintenance, accepting safety-based, but get away from time-based maintenance altogether and improve the utilisation of the plant. And we'll be able to share the engineering capability across fleets then. Levelised cost of electricity, these are different investment mechanisms which could reduce it by different parties. And just for this, I'll finish with our design's all about economics and the market requirements. It's got to be commercially investable for utility operators. The economics, as you saw by the sensitivity analysis, are dominated by interest rates and getting cheaper finance. As I said, whatever we do nowadays, we should be doing market-driven requirements alongside our innovative engineering, because if we don't, we are not going to succeed. And let's face it, the UK, although we do good stuff, is not exactly the world leader in manufacturing anymore, unfortunately. So we've got to have an edge with what we do. It's not just a nuclear reactor. Present company accepted on the call, a lot of reactor technologies have been developed from universities, and they haven't taken a holistic approach to a power station design in the main. And the last one is modularisation is a solution to reducing costs, not a design in itself. For me, the proof's in the pudding. In our civil aero business, when I joined the company, which was over 35 years ago, we produced 36 large engines per annum. We had about 8 carriers as customers then, up to COVID, and of course COVID's hit civil aero very hard. We had over 140 carriers who used our aero engines, and we produced over 550 large engines last year. And each one, with an integrated supply chain, took 5 days to build. So from over 200 days down to 5 days. And actually, it was only 20 years ago that it was still taking over 100 days for a large engine. So the learning curve's real. We've got experience of it in this country, and we've got to take advantage of it. I think lastly, for me, applying it to education, this does span the whole lot. So we do cover all STEM topics. We bring in scientists, pure physics, materials, chemistry. We do manufacturing, engineering, design for manufacture, metrologists, manufacturing flow, supply chain professions, as well as all the design engineering systems, normal skill sets that you'd need for this kind of process. And for this, of course, it's civil engineering as well. So fascinating. I get to do some great things with the team, really enjoy it. And I am passionate about youngsters coming into it. It really sort of gets at me why we're not attracting more. I kind of agree with Gary that we always target the same market, but I'm not sure that we all do. We spend an awful lot of time on STEM, and we know that we got to go into primary schools because secondary schools is too late. And the other thing that really galls me is we've got fantastic diversity in our business, which we're proud of. The one area that we haven't is in female engineering. And scientists are fine. We get a higher proportion on pure sciences. But engineering, Again, when I was at university with George Stevenson, the actual numbers of women were less than 10% on the engineering courses, and it hasn't really improved much. I think that's it. Thank you.
Thank you very much, David.
Thank you.
I would agree with you that 10% is probably about the right figure for women in engineering, and it's a shame. Something needs to be done. I mean, certainly, I see the government via levy giving incentives to under 16s, under 18s, but maybe they, you know, if you provide the finance, people will start to look. And I think that there needs to be some sort of, the bigger companies are adhering and bringing in a larger proportion of girls to engineering or apprenticeships or whatever. But it's the smaller companies that aren't doing it. If I'm being honest with you, it's a difficult one. It's a little bit of legacy. We never did. We're not going to. We're not starting. And maybe it's a stick and carrot. You know, if the incentives were weighted the other way, they might start looking. I don't have the magic answer here, I'm afraid, for women in industry. So it's a tough one. I don't know whether lots of people have got different views. Maybe we're going to throw it open on the floor after, because I see a lot of comments there. But going on to the nuclear side, we've got a question from Mark Dickens. What are the projections for nuclear fuel availability going forward, especially as everyone else will be trying to zero carbon too?
It's fine, actually. I mean, the civil reactors use very low enriched uranium, so it's less than 5% enrichment. And there's plenty of uranium mines around. So, and they're not all in Kazakhstan, Uzbekistan, and one thing and another. They do have them in Australia as well, for example. So they are in accessible countries. There's uranium on most continents, not Europe. But it's quite accessible. Uranium isn't really the issue. The uranium ore.
And then another question that might put it into focus, because I didn't. There's the one bit. I mean, I saw the values, but I didn't quite know what it meant. So one of these modular reactors, what could it power? I mean, what sort of scale could it power?
Sure, it can power a city the size of Leeds.
Wow. Okay. All right. So yeah.
Oh, one can power a city the size of Leeds. Yeah.
Yeah. So it wouldn't take many, and all of a sudden this country could be, you know, strategically placed. You could power. So Leeds, as I understand it, and I don't know whether it's the Leeds Bradford area, but it's at least 500,000 people in Leeds. And if you count Bradford, I don't know if that's counted. We're probably up to about 750,000.
It's Leeds is around 500,000 people. That's right. Yeah.
So it would. So that's what you're suspecting. It would power. That's an incredible. And what's the government's view? Are they
fully behind it, actually? The issue we've had is that up until Boris Johnson got in power, we hadn't got a government that could do anything for 10 years or make a decision. Unfortunately, we've now got the event we're in, and all we need really is a plague of locusts as well, to be honest, you're thrown at it. But it's very much in their thoughts. We've had the minister and directors in Bays already onto us saying how can they help during this period. The consortium's doing pretty well, actually. I'm surprised, pleased and surprised, but the utilisation figures coming through for the first month, I thought we'd see a significant drop in value. Doesn't look like it. It's probably less than 10%. So the remote working with the right tools is working reasonably well.
Well, if I was, I'm not in government, but if I was in government, one of the ways out of this would be public projects, and I would have deemed this to be a public project. And this, you know, I mean, Boris seems to have only the fifth runway at Heathrow, but this would be up there, in my opinion. Obviously, safety number one. I mean, I would take a guess that every safety aspect is covered, but I mean, how stringent has the safety test been?
Oh, massively. I mean, it goes through an enormous amount of verification and validation at every level. It has to, and the regulator, government regulator, the ONR, has to witness all that. Similarly with the modules, they go through destruction testing. If you look at it, the civils, as an example, the civil structures got to withstand the impact, a direct impact of a 777 jet,
Okay.
not actually breach the containment area.
Okay.
So I mean, it's well over designed for safety. They always are. I mean, this is the latest generation as well, so it's got natural circulation, backup heat sinks, so it's got the entire lot. Sure.
So the other thing that struck me, because I did see it with Bombardier, what I saw with them when they were building their new factory, I had a virtual tour of it, a virtual tour. So obviously, I would have thought that you could do the same with your modular reactor. I would have thought you could do a virtual, which would have been the ideal tool to sort of show kids, I would have thought. I mean, you can't.
Yeah,
So
you can't win. You can't win with it though. You see, because it takes. You can do it for marketing kind of thing, I suppose, but the reality is we've been absolutely focused on getting our design maturity from what I said earlier first, and making sure we're ready to enter regulation, the critical path. And we need the government commitment before we can go into actually starting developing manufacturing facilities as well.